In this lesson, we're going to learn how to build confidence interval for the difference of two proportions. To understand this, we're going to use the example, which gender uses Twitter more? I have to give StatsMedic a shout out for this activity. So a recent random sample of 200 US females revealed 110 use Twitter regularly. A separate random sample of 150 males revealed that 60 use Twitter regularly. Construct a 95% confidence interval for the true difference in proportions who use Twitter regularly, females minus males. So first of all, let's just kind of talk about what we've got here. We have two separate samples of males and females. And we're seeing that 60 out of 150, which would be 40% of males that we selected are using Twitter, whereas 110 out of 200 would be 55%. So for our samples, we see this different, 55% versus 40% using Twitter. But we want to see, is this enough to say, you know what, we've got convincing evidence that there really is a true difference. So we're going to try to capture the true difference, our population parameter, by just beginning with our samples. So let's state what we need to do. So in our state, we want to make sure that we're talking about our parameter and we define what it is and our confidence level. So I'm stating we want to construct a 95% confidence interval for P sub F minus P sub M. You'll also see this written as P sub 1 and P sub 2. I just prefer the subscript of F and M because it helps me keep it straight in my brain what I'm talking about, the females and males, where this difference is the true difference in the proportion of females and males who use Twitter. It may even be better here to really show that we understand the proportion to say that we are talking about US females and males who use Twitter. At some point, you want to mention your sample statistics. Now, I typically do this down in the do portion, but I just want to emphasize, why are we even doing this? Well, that's because our p hat for females is 110 out of 200, which is 0.55, whereas our p hat, our sample proportion of males, is 60 out of 150, or 0.4. So we have some evidence to show that there's this difference, a 15% difference for females being higher. All right, so we're going to go into our plan section, which is where we name our test and then state our conditions. So I'm stating if conditions are met, we will construct a 2 proportion Z interval. You will also see this referred to as a 2 sample Z interval for proportions. Now, as we address our random condition, one additional thing that we must be sure to address is that we have random samples coming from 2 independent groups. So I want to emphasize this, making sure that our groups are independent with no overlap in our condition. So I'm stating that independent random samples of males and females were selected. Next would be my 10% condition. So I'm going to be sure that I'm addressing the 10% condition for both samples. It has to be, your samples both must be less than 10% of the populations. So I'm saying that 200 is less than 10% of all US females, and then I will also state that 150 is less than 10% of all US males. For the large counts condition, this, remember, is where we are making sure that we have at least 10 successes and failures, but since I have 2 groups, I have to have it in both groups. If you're talking, or if you go to use your formula, you make sure that you are checking using p hat. As you don't know true p, you would do n times p hat and n times 1 minus p hat. But another suggestion would be not even to write that, because if you use p hat when you're supposed to use p and vice versa, if you're using the wrong one, you will get knocked points on the actual exam. All right, so I'm going to say that I have 110 female Twitter users. I have to also address the males. So there are 60 male Twitter users. And let's see, 90, because it adds to 150. So 90 male non-Twitter users. And then I'm going to state that both are greater than or equal to 10. So both are greater than or equal to 10, so our conditions are met. On the actual AP exam, when you're verifying your conditions within your free response, it's very unusual for the conditions not to be met. If they are not, I would just cite your concern and what issues that causes, but to actually continue with finding your interval. Now, in a multiple choice question, they could very well address and ask, are conditions met? Is it safe to proceed? That sort of thing. So as we go to the do, I encourage you to pull out your AP formula sheet. On the first page on the lower left side, you're going to see that it is your confidence interval is equal to your statistic, which in our scenario is p hat of females minus the p hat of males. Okay, so it's a difference in our proportions plus or minus your critical value, it says. So when we're talking proportions, that's going to be z star, our estimate for a standard deviation, times the standard error of your statistic. Well, if you go to your standard error of your statistic, that's going to be standard error of p hat for females minus p hat for males. Okay, now what is that actually equal to right here? And that's on your formula sheet. So notice this formula is calculated nearly the same as what we do with one proportion, so p hat times 1 minus p hat over your sample size, but notice that we are adding it together. And if you think back to when we did sampling distributions, when we combine our standard deviations, and we're doing standard error, the next best thing, when we combine them, our results will not vary less, they will vary more. So where you can like subtract means, you can never subtract standard deviations, you end up adding. Right, so I'm going to show my calculations now. So this would be, and I actually showed this above, but if you didn't show it above, you would show it right here. 110 out of 200 is 0.55, and then my sample proportion of males was that 60 out of 110 used Twitter, so that would be a 40%. So my difference would be 0.15, 15% plus or minus. My Z star for a 95% confidence interval is 1.96. A reminder of how you do that, that's going to be inverse norm for 95% if you don't recall. And then times, let's see, going to fill in here, well, for p hat 1 would be our p hat for females would be 0.55. 55% are Twitter users, so that means 45% are not. Over 200 females added to 40% times 60% would not be for males, and 110 males were asked. So use your calculator, go ahead, and remember that this part right here is also known as your margin of error. Add your margin of error on and take it away from the difference, your observed difference in your statistics, also known as your point estimate. Okay, so I get 0.046 to 0.254. And let's state our conclusion. So as we state our conclusion, remember that your confidence lies in the ability of your interval capturing the true difference. So I'm stating that we are 95% confident that the interval from, and I state my interval, captures the true difference, and I state a direction here, which might be overkill, but I want there to be no question, of females minus males in the proportion of females to males who use Twitter. And now I'm going to say, we estimate that females use Twitter 4.6 to 25.4% more than males do. So let's talk about some important points to remember. So one would be that with our conditions, we need to have samples drawn from, I should say random samples drawn from two independent random samples or from two groups in a randomized experiment. And remember that this is called a two proportion Z interval, and the goal is to capture the true difference in your proportion. Okay, so this notation is your true proportion, it's your parameter, whereas when you're using the p hat, that's your statistic, and that's your observed difference. And that's, why you're trying to figure out, is there a true difference? Additionally, in general, your confidence interval is constructed by your point estimate, so your observed difference, plus or minus your z star, times your standard error, which would be your first p hat times 1 minus p hat, so proportion of failures over your sample size, and that gets added. Super important, but again, that's on your formula sheet. Get used to looking at it, finding where things are. It's a huge help in the middle of an exam where you get stressed over your second sample size. Okay, so when you go to interpret your confidence interval, think about what the interval can contain. So in our Twitter example, our interval went from a positive number to a positive number, which indicated to us that P1 was greater, right? So we saw more females, and we have convincing evidence that there is a difference. Whereas if it goes from a negative value to another negative value, well, that's going to mean, like in our scenario, that the males would have been greater. So P2 is greater. Now, I usually set up my intervals from the beginning so that I'm dealing with positive numbers. The observed one that's larger, I put that one first. It's just my personal preference. I find it easier to talk about positive things. I find that my words get mixed up when I sometimes start talking double negatives. So your third scenario is that it goes from a negative to a positive. And this is where we don't really know which is greater, okay? Because we've got a negative, and a positive, or more importantly, we could say that 0 is included in that interval. We don't know which is greater. And it may actually be that there is no difference at all.